We're up. Thank you for joining us. We're continuing our class here at Lindsley Avenue on why I believe. And tonight is kind of a follow-up on the argument from design. And so what I want to talk about tonight are some examples of where the world, the earth, the universe appear to have been fine-tuned. The example I used last week as a way to think about this is the Goldilocks principle. Everything seems to be just right. And so I want to talk about some of that. As we start off here, I would suggest to you there's powerful evidence from the sciences of what appears to have been the fine-tuning of the universe, sometimes called the anthropic principle. Anthropos is the word for man or humanity. And so it's this principle that things seem well suited for us to be here. It appears to be incredibly fine-tuned from the moment of its inception to have intelligent life be here on the earth. This complex and very delicately balanced set of initial conditions are really hard to explain from chance. I would suggest it's an example of the personal nature of this cause that we've been talking about. So far, we've said there needs to be a cause for the beginning of the universe. There needs to be a cause for design, a designer. There also needs to be some source of good for there to be morals, some way to know something is good and something is truly evil. But that doesn't, so far, tell us anything about whether this cause or designer cares anything at all about us. It could easily be, caring about Planet X somewhere. We just happen to be along for the ride. So why would we think this creator, this cause, is a personal creator? Some world religions posit gods or goddesses, but they're not always personal. In fact, some religions have a very impersonal idea of this cause. So if things are finely tuned, right, that implies attention to detail. That implies making sure that things are Goldilocks, just right for us. The scientific evidence, so I would suggest here, kind of underlies this idea of the philosophical arguments that we've been going through. So think of this, as I say here, the Goldilocks principle. More than that, this relationship, this fine-tunedness, again presents the idea that the Creator really cares and is focused on us here on the earth. Though we are very small in size compared to the universe as a whole, we are the most complex structure in the universe so far discovered. We can put that caveat in there. And so the entire universe, how strange it would be if the entire universe seems designed for us to be here, life to be here on the earth, and it for all to have been simply a cosmic accident. So consider these statements from scientists. Here's a statement from this man named Joseph Bauer from his book on page 43. It says, "We've discovered that the existence of human life and intelligence on Earth is the happy result of a long series of extremely fortunate circumstances. If any one of them had been seriously altered, we would not be here." So I'm going to present in a few slides several of these fine-tuned things that have to be the way they are. Scientists don't disagree that these are, in fact, exactly the way they need to be or we wouldn't be here. They're simply going to argue, aren't we the lucky ones, that they're all exactly the way they need to be. Here's another one. This is from Fred Hoyle. He was a British astronomer, so Fred Hoyle. "The odds of us being here by chance are worse than the odds of solving a Rubik's Cube blindfolded." I hate those things. I have always hated them, blindfolded or not. The way I would solve one of those is I would peel the stickers off because they annoy me to death.
You could pop the center off one of them.
I have never learned that. A hammer to it is what I might have taken. But this man here is not a Christian. And so he is saying the odds of us being here are lower than blindfolding somebody and having them solve a Rubik's Cube. So when you get statements like this from scientists that don't have a Christian viewpoint, I try to pay attention to. Here's another thing he said here. "Indeed, such a theory that life was assembled by an intelligence is so obvious that one wonders why it's not being accepted as self-evident. The reasons are psychological rather than scientific. So what I tend to think of it is this way, right? If you have ideas on the table and God is an idea on the table, from a scientific viewpoint, you deal with natural causes. And one of the basics of science is you don't appeal to magic, or they would say super magic, for supernatural causes. So the idea of God being a possible explanation for anything has already been pushed off the table. And so if you eliminate God by default, there can't possibly be a creator. Whatever remains, Sherlock Holmes, no matter how improbable, must be the answer. And so this idea here that if you were allowed to consider design, if you were allowed to consider a designer or a creator, Sir Fred Hoyle here says that one wonders why that's not self-evident. That of course design and a creator have paid attention to us. It's all up here. Cannot possibly be God, therefore it has to be something else over here. Here's Paul Davies. He wrote in The Mind of God, "The rules look as if they are the product of intelligent design. I do not see how that can be denied." What can be denied, if the only other option is you can't have some designer in here, so therefore we've got to chunk that out. Here's another statement he made. "It's hard to resist that the present structure of the universe, apparently so sensitive to minor alterations in the numbers, fundamental constants, different adjustments and interactions between the forces, has been very carefully thought out. The seemingly miraculous concurrence of numerical values that nature has assigned to her fundamental constants must remain the most compelling evidence for an element of cosmic design." Do we hear that in the news? Do we hear that in our universities? No. It's kind of one of these hidden secrets. They'll talk about design, design, design. Many times they'll capitalize design when scientists will talk about it. Oh, but don't dare suggest that somebody ought to go to a church or some religious kind of viewpoint, because that's actually off the table. The impression of design is overwhelming. We're not talking about an option that ought to be considered. This guy, when he's speaking plainly, is saying it's overwhelming. Sir Fred Hoyle is like, it's Rubik's Cube blindfolded. The reasons for not accepting this are probably psychological rather than scientific. So let's look at some of these fine tunings. Remember, next week is the time I was suggesting have coffee. So no matter what you think of tonight's lesson, next week is the time to have some coffee in the early afternoon, please. Because I could say something about it. It'll just be more intense. It's going to be mind-bending. It causes me to have to think hard for next week. But this one will be a little easier, so here we go.
So it's talking about fundamental
constants and physics and things like that. And that's what these next examples are going to be, or some of them. And why, if they were slightly different from where they are, things wouldn't work. Okay? So, I bet most of us haven't thought about the electromagnetic coupling constant today.
Just the other day.
Just the other day. All right? If larger, you wouldn't have any chemical bonding that would occur between atoms. We all need chemical bonding, not just so that you can find your significant other or somebody of interest, but so that you can have things even as easy as water, H2O, molecules formed from atoms forming together. And if you would have elements more massive than boron, which is one of the early elements on the periodic table, would be unstable and would have fission occurring. And if smaller, you wouldn't have any. It's got to be exactly where it is. It's at the exact point where you can have chemical bonding that can release, right? The energy is extracted in our bodies from the body breaking apart molecules, and it releases energy. And so if the constant is too strong, you can't break these molecules apart. And if it's not strong enough, they don't form in the first place. So here's an example of this one. This is the number that determines the strength of the force exerted in a chemical interaction. Originally, it was related to the charge of the bodies. Think of sodium chloride. Sodium, as I recall, has a positive charge. Chloride has a negative charge, NaCl. Na usually had a plus, and Cl had a negative on it in chemistry. And that's the electronegativity aspect, where they would pull each other together, and that's why you have salt. You don't want sodium by itself. You put sodium in water, you're going to have an explosion. That was always the prank people wanted to try in high school, was to throw sodium in a toilet. You would have an explosion in the boys' room. But sodium chloride is what makes our food taste better. If you're just chunking chloride itself, right, we know how that is in the pool. Together, by the chemical bond between them, is what you need. So it would not work if this constant, this force, were slightly different one way or the other. The second one here, this one's a little harder, the decay rate of the proton. Things in the universe, if you're not going into the depth of quarks that make up protons, neutrons, and all that stuff, but you have protons, neutrons, and electrons. Protons and neutrons are in the nucleus. The proton is a very stable particle, or conglomeration of quarks. The decay rate of the proton has actually yet to be measured. It's supposed to be proton decaying on average in about 10 to the 34th years. That's a long time. So how would you ever have that? Well, one way to do it is to get 10 to the 34th protons in a tank and wait for one of them in a year to decay. Well, that's a few too many protons, so they end up getting about 10 to the 28th, 10 to the 29th, and they let it run for a while and look for them to decay. What's the problem? Our bodies are made up of protons. If you had protons decaying in your body itself would be giving off radioactivity. You'd end up poisoning yourself from your own protons decaying. As it is, it's just and we have a lot of protons in our body, right? If you were to say zap and count the protons in your body, there's a lot of them. If that decay rate of the proton, instead of being 10 to the 34th years, were as low as just 10 to the 27th years, that's a lot of years, then our bodies would be throwing off radioactivity. It's like walking around with a little piece of uranium strapped to your brain. It would not work for life. And if the protons don't decay at all, then you don't have the matter distribution occurring in the universe that you need.
What happens to the proton and uranium when it decays? Does it become something else?
It's the nucleus of uranium that splits. It's not the proton itself. The proton has never yet been observed to decay, but theory that's well established says it will. The question is how long on average, and they've ruled out up to 10 to the 34th. It's good for us. If it decayed once every 10 to the 27th years, life wouldn't really be possible because life itself would poison itself by its own matter inside our cells decaying and zapping us with radiation.
This is what happens to my knees.
Number 3, I'll work through these. I do have little explanations for them. The strong nuclear force. We had the electromagnetic, which is what allows chemical bonds. The strong nuclear force coupling constant. This is what keeps the protons and the neutrons together as separate particles, right? The strong force, allowing a proton, allowing a neutron. If stronger, you wouldn't have a hydrogen atom at all. Hydrogen is the most abundant element in the universe. Nuclei, essential for life, would therefore be unstable. If weaker, you wouldn't have anything else other than hydrogen. It would all be hydrogen. So this, the strong force is on the scale of the nucleus. The electromagnetic force is on the scale of the atom. The atom is mostly empty space, whatever that means, we don't have anything in it. But the strong force is confined very strongly to the inner part of the nucleus. If that force that keeps the proton together, the quarks and the proton together, were just a hair different, atoms would not look like they are, and we wouldn't be here. Now, take one of these. You say, well, it has to be something, right? What I'm trying to do by just going through these things is, it's one after the other, after the other, after the other that leads some of these scientists willing to consider that the impression of design and the fine-tuned nature of all these numbers in physics are just astounding, because monkey with any of them, right? Let me go up to the dials on the machine, and if my elbow hits one of them, the machine doesn't work anymore. Imagine the control panel with hundreds of different dials. They're all set exactly the same, so that in the test chamber of the universe, as it were, we are here. We are here. Then you have one for the weak nuclear force. This is what allows the nucleus to decay. Back to your uranium example, this is what allows fission to occur and for things to split off. Again, if you
strong nuclear,
that was a strong force of some sort. The weak force is how you get subatomic particles, the beta decay, the alpha proton decay, things like that. The value of this constant, again, is just right. I'll keep going. How about the ratio of protons to electrons in the universe? It's not a one-to-one. In the universe as a whole, if you had 1% electrons compared to the number of protons, you wouldn't end up having galaxy and planet formations because you wouldn't have the proper atomic material. Why is there this delicate balance of protons and electrons? Why? Well, it could turn out to be something else, right? Give me the dials on the machine and I could put one higher or lower than the other one. The ratio of the electron to proton mass, which by the way is like 1836 to 1. The proton is 1836 times more massive than the electron. It turns out that feeds into all sorts of calculations that describe the fine structure constant of the universe and all these other things, that if that mass ratio between the proton and the electron were 2,000 to 1 or 50 to 1, the universe could not be able to exist as it is. More closer to home, less particle physics.
All right.
Okay, it'll be good for this one, right? We can think through this one. 23.5%. The Earth's axial tilt, right? That's why we're beginning to experience spring leading to summer. The Earth is tilted at about 23.5 degrees. Okay, what that allows is for seasons. Consider a couple of alternatives. Venus is about 0. It's like simply a spinning top, no real tilt at all. What problem would that create for the Earth? Well,
I don't think we'd have the North and South poles. I don't think we'd have snow.
Well, we would have a ton of snow at the North Pole because it would never get very warm at the North Pole. But what would happen at the equator? The sun would beat down on it right here, straight out all the time, as opposed to it doesn't wobble, but winter, the sun is low in the sky to us. In the summer, the sun is high in the sky. Did I say snow in the sky? I think I did. If it were straight 0, it would all hit right here. So it would be very, very cold up here, very, very cold down here, probably too hot in the middle. You'd have a couple of zones you'd be able to live on. Compare that to Uranus, the planet number 7 out there, I think, right? It's at 98 degrees. Just assume it's at 90. Head on to the sun. Well, what's the problem with that? Well, that would mean for at least several months of the year, if the sun is the camera, right, and I'm tilted at 90 degrees instead of 0, the North Pole is pointing straight at the sun for like 3 months out of the year.
Are you saying Uranus does that?
It's 98 degrees, yes. It's actually
like 100 degrees pointing towards the north of it.
Points toward the sun.
It's spinning like this.
Yes, it's on its side. It's on its side, which is bizarre. But back to the Earth. Let's stick to the Earth.
You know that for a fact?
What?
You know that for a fact?
I do know that for a fact. 98 degrees. So I'm back to the Earth. If it's at 90 degrees, pointing straight at the camera, right? A third or a fourth of the year, the North Pole would be pointing straight at the sun. What about the South Pole? We wouldn't have any sunshine at all.
Freezing cold.
Imagine for 3 months that half of the Earth would essentially have no sunshine. How good is that for plant life, right?
Go to Alaska.
Plants don't grow very much year-round,
You're
right?
saying it's doing this over here.
It would be doing this. Half of the year you would have sun all the time. We have a little bit of the Earth. It has the land of the midnight sun, right? But that at least is down at the horizon. Imagine it being overhead for 3 straight months, right? Imagine if you've been to the equator, the temperature of the equator over half of the globe for 3 months. That would be kind of bad. No, that'd be really bad. The Earth's rotation period, which is how many hours? 24, right? I'm trying to get a little, come on. Everybody can join in for that. 24 hours. The planet Venus takes several hundred days to complete one rotation on its axis. What problem does that create? Well, suppose the Earth took 200 days to go around. A day was 200 days long, right? What is that? That's 4,000 hours or something like that to go around. That means you got nighttime for like 2,000 hours. What does that do to your plants? What do you think that does to the temperature? It gets cold here at night, doesn't it? At least in the wintertime. The sun's not shining. Earth radiates its heat out to the sky and to the space. If it was doing that for 2,000 hours, I think it would get rather cold. winter would certainly be coming, right? And as it slowly turned away from the sun, not only would it start getting colder, things would start freezing out. That'd be really disastrous. Suppose the Earth spun in 2 hours. Well, the faster a planet spins, the faster the winds are on the planet.
Yeah.
Jupiter goes at about 9 hours, and the speed of its atmospheric winds, is like 1,000 miles an hour. That wouldn't work very well for us either. So I'm not necessarily suggesting there's anything magical, as it were, about 24 hours. But if it were 1,000 hours rotation period or 3 hours rotation period, it would be really bad. So one at a time, yeah, I can buy a chance occurrence of one of these. You get all of them added together. That's the cumulative case for the Goldilocks principle. Continuing on with this one, the gravitational interaction with the moon. We don't definitely need that.
That was good. I didn't do that with each point.
That would wake the audience up, that's for sure. The moon going around the Earth contributes to what most directly?
Tides.
The tides, okay? Where the moon is gives tides, and one of the importance of tides is it stirs up waters on the coasts near the continental shelves.
Seashells.
Water comes in and out. Yeah,
This person is just determined. Silence.
that's what you got to do. Silence all phones before class begins. Where the moon is generates the tides, which are very important. If the Earth did not have any tides, if the Earth had no moon, life in the ocean would look really different, because it's the cleaning of nutrients and bringing more stuff in and out every day with the tides. Well, what if the moon were 10 times further away? It's 230,000 miles roughly on average. Suppose it was 2 million miles away. The tides would be very tiny. On the other hand, suppose the moon was only 10,000 miles away. The tides, depending on where you are, might be 3, 4, 5, 6 feet. Sure, the Bay of Fundy in Canada has 60-foot tides every day, which is bizarre.
Wait a minute, the moon is like 30,000 miles away.
No, the moon is 230,000 miles away.
Oh.
230. Okay? What I'm suggesting is if you've got 3 to 6 feet tides now, if the moon were only 10,000 miles away, imagine a 100-foot tide every day. That would be really bad. A tidal wave every day that the moon brings in to shore. We'd all have to be living in Denver. Now, life could exist in Denver, but certainly it would be a very different place. So the moon being there is very, very important. It also tends to stabilize the Earth's rotation. Put a top on the table, spin it. We all did that as a kid or recently, depending on what you want to do, right? Yeah. Spin the top on here, what happens? This spins great for a little while, and then it starts doing what?
Wobble.
Right? It wobbles and it'll fall over. Well, having a moon and the Earth tugging at each other does a great deal to keep that Earth's axis very stable. It still wobbles a little bit. The North Star was not the North Star 20,000 years ago, because the Earth does kind of wobble a bit. And 10,000 years from now, the North Star will not be at the north direction. You have to point somewhere else and try to find your way at night. But the moon keeps it much more stable than it would ever have been if there were no moon. The magnetic field. I have seen the northern lights once in my life. It was actually driving back from Alabama, of all things. I got out and looked and saw red scattering in the sky. It was northern lights. That I'd never seen them any other time other than that. But the northern lights are where electromagnetic particles from the sun come in through the Earth's atmosphere, and it charges material in the atmosphere. It's like, think of a static discharge. That's not what it is, but imagine that. Well, if the Earth had no magnetic field for those particles to interact with, then all that would just slam right into the surface of the Earth. That's really bad. Mars does not have a magnetic field. And so the surface of Mars gets hit with the sun's radiation and those charged particles directly. The moon doesn't have a magnetic field. And so the particles hit it. And over time, those strong particles, all that radiation, causes biological damage to living structures. One of the big fears they had, in fact, there was some movie made, it was about the last Apollo mission. They were on the moon and a solar flare happened, and they were toast. because the lunar module was not nearly thick enough to stop that stuff. So there was great danger when the astronauts were on the moon if a solar flare happened, because nothing would stop it. If you're on the Earth and a solar flare happens, the worst that occurs to you is the radio goes out, right? You may have problems with radio or something like that. But because we've got the magnetic field protecting us.
What did you say about Mars?
Mars has no magnetic field either.
So they think it's not made out of iron, then, right? Or does it? What's its rotation?
It's rotating, but they don't think the core inside Mars is molten the way the Earth's core is.
Oh, yeah.
So it's an electromagnetic effect. But with the magnetic field of the Earth, if it were not here, that would be a problem. And also, if it were very, very strong, that would also be a problem. It's right about where it needs to be. So again, any one of these, sure. It's got to have a magnetic field. It will have some value. How fortunate. Remember the language there? We're here as a result of a series of fortunate accidents. The electromagnetic coupling constant. Well, it's got to be something. Look at it. It's right where it needs to be. Boom, 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 boom. All the way down the list.
Like you got to think of the asteroids. They all kind of divert to the north and south of the Earth, right?
Well, most of them are out between Mars and Jupiter. And you got other ones that are
So I'm talking about
circling
when they have shooting stars, like when they
for just meteoroids. They will come in, and they usually come from the direction of the Earth's revolution around the sun, smack into the Earth as we're moving through. But we'll put that one off for just now. The thickness of the Earth's crust, if it were too thin, right? Imagine volcanoes just by walking around on it. You step on something, and it's like walking on a sheet of paper. You step through it, molten lava comes through because the Earth's crust is a millimeter thick. Aren't you glad it's not a millimeter thick with lava underneath everything? On the other hand, if it were 1,000 miles thick, that poses problems too. The Earth's crust is always in a state of being replaced. In faults, there is subduction that occurs. One plate will go beneath another plate and kind of sucks the Earth's crust back into the inside of the Earth where it melts. And then you have other stuff coming out of the Earth through volcanic action. That constant recycling keeps the Earth's crust fresh. A planet with no volcanic activity and no plate tectonics would not be a good place to live on for very long because the material of the Earth's surface or the planet's surface would not be replenished. So if the Earth's crust were 1,000 miles thick, we'd run out of good stuff, right? Volcanoes bring stuff back to the Earth, and they have throughout a long, long, long time. If it's too thin, volcanoes everywhere. You go out and try to dig up and put flowers in the ground, and you got a volcano because you punch through the Earth's crust. That's a paper sheet thick. The albedo of the Earth. Albedo is the reflectivity of a planet, how white the surface of the planet is, how much it reflects it, how much heat gets reflected back to the Earth, to the space, versus how much gets absorbed. Think about it this way. If you go out, even on a cold day, and you're wearing a dark shirt, eventually, if you're in the sunshine, that shirt starts feeling warm. You ever felt that? Because it's not reflecting sunlight, all the sunlight, even on a cold day. And granted, if it's 100 below, nothing's going to help. But if it's 30 degrees and you're wearing a dark shirt, you can start feeling really warm. Your shirt will get warm because it's absorbing the infrared heat of the sunlight. Well, the Earth, as a sphere, has a reflectivity to it, right? A black shirt is going to catch most of it. I'm sure a mirror shirt is going to reflect it all, right? You freeze to death wearing if you had a mirror shirt because it won't catch any of the heat. Well, the Earth has a certain albedo, and that's a measure of how much of the incoming sunlight gets reflected back to space. Clouds reflect a lot of the heat back to space. If the Earth were completely covered with clouds, most of the heat of the sun would get reflected back to space. You remember the idea of nuclear winter that used to be talked about in the 70s and 80s? That was one of the big concerns they had, was if you launched all these nuclear weapons, besides frying us all or giving us all third arms, the smoke and the residue of the nuclear explosions that we're concerned with would give a cloud cover that would cover the Earth, and the Earth's temperature would drop quite severely. That's changing the reflectivity of the Earth's atmosphere. So if you had no clouds, all of the heat from the sun would hit it and would really drive up the heat. If you had 100% clouds, none of it would. Isn't it interesting that it seems to be able to modulate a fairly comfortable temperature for life somewhere between 30 degrees and 100 degrees, again, based on the albedo here. The carbon dioxide level in the atmosphere. Let's talk about global warming. If you didn't have any carbon dioxide in the atmosphere, first of all, plants would die. That's plant food. But if you had too much, then it's that greenhouse gas, right? That's the worry, is that it'll reinforce absorbing heat coming in from the sun and heat we generate, just like a greenhouse does. You know, it could be 10 degrees outside, but in a greenhouse or your locked car in the sun, the inside of your locked car may very well be a lot warmer than it is outside because of this greenhouse effect, and carbon dioxide can increase that. We hear a lot about this, of course, too much or too little could be really bad. It turns out water vapor, water in the clouds and in the sky, is actually a more potent greenhouse gas than carbon dioxide. And if you have water vapor too much, right, you're going to have a rain world. All it ever does is rain all day. Too much water vapor means it's going to have too many clouds, right? Seattle, just it's going to be bad. You're going to have too much water vapor. That would generate a runaway greenhouse effect. You know, if you think of movies where people have been lost in the jungle, usually it's hot, steamy, and rains all the time. And so the rain is a product of the heat. So if you have too much clouds, too much water vapor, it's going to reinforce and make it much, much too hot. So carbon dioxide and water vapor. How much oxygen is in the atmosphere? We have about an 80-20 split. I know it's not quite, but 80% nitrogen in the Earth's atmosphere, about 20% oxygen. It's not quite. I think it's 78 or something like that for nitrogen. 20% oxygen. That seems to be enough that we can catch our breath, right? Well, if 20% oxygen is good, why don't we try to get the atmosphere to 90% oxygen?
Yeah.
Well, let's think back to Apollo 7.
Catch fire.
Apollo 7. That was in 1967. They had the 3 astronauts in the test on the pad. They locked them in the Apollo capsule. They were in a pure oxygen atmosphere. And unfortunately, they think a wire had a short, and it just took one spark, and at 100% oxygen, water will burn. Not quite, but that's the idea. 100% oxygen, you can't put things out. And so if the Earth had 80% oxygen even, think of a lightning strike that catches fire somewhere. You think if we got wildfires now, it would be awful. But if you had 5% oxygen, life needs oxygen because our metabolism pulls in oxygen through our lungs, and that's what keeps us going. You need roughly this amount of oxygen. Yeah, we'd get by at 25% oxygen, I'm pretty sure. We'd get by at 15, but it needs to be somewhere in this vicinity. So, ocean to continent ratio, I'll get off of this. I think this is the last one. A hooray is perfectly legitimate here. If you had 90% land and only 10% oceans, that wouldn't get enough water vapor in the atmosphere. On the other hand, if you had 90% oceans and only 5%, you'd be at the risk of the greenhouse effect of too much water vapor in the atmosphere. The issue here is there's been over 100 of these, and I assure you I had no intention of bringing in all 100. 100 of these have been identified, each of which by themselves, you might think, it's got to have a value, so why not be 20% oxygen? Isn't it lucky for us that they all just happen to be right about where they need to be so that we can be here, okay? Now, when you're talking to somebody that does not believe, they will typically come up with the idea that, well, the only reason we are here to observe these things is because these numbers have the values they do. If any of them were different, we wouldn't be here wondering about it. So in an infinite universe, something had to happen here on this earth, or in an infinite multiverse where there's infinite universes, which is the current thing that's kind of in vogue. We're in this universe with all the numbers here. There's a universe next to us, whatever that means, where the numbers are slightly different and there's no life in that one. So in an infinite number of universes where you set these dials randomly for all these numbers, we happen to be in the one where it's possible. So why are we surprised? Because if any of the numbers were different, we wouldn't be here to be discussing it. Well, here's what one of my favorite philosophers, William Lane Craig, and his friend Richard Swyburn said about this. By the way, he's been engaged in a number of debates with people who don't believe. He's one of the most well thought out individuals I have ever read. When I taught a class at the School of Preaching, I gave them a debate and asked people to find the arguments for, against, and to rewrite them so they could pull each argument out separately and then evaluate it. So here's what he said. Suppose 100 sharpshooters are sent to execute a prisoner, firing squad. Okay? So I'm standing up here, and as some of you may want to be doing now, shooting me to end the class. Okay? You've got, all of you have the gun, and you're sharpshooters. You're not just random people who've never seen a gun before. The prisoner survives, right? The 100 people ready, aim, blam! 100 of them, and they're all good shooters. Okay? Could one of the shooters miss? Sure. 5? Maybe. But they all go, blam, fire, blam, right? Prisoner's still alive. Prisoner's still alive. The prisoner should not be surprised that he observes he's not dead. Think about it. If I were dead, I couldn't possibly observe that I was not dead. I mean, I wouldn't have any observation powers at all. So if I survive, I'm very surprised that I'm still alive, right? Because I did not expect to be alive. After all, if we were dead, we couldn't observe. So think about that parallel to the universe, right? If the numbers were slightly different, it is true that we would not be here to observe it because we'd be like the prisoner that had been shot by the 100 sharpshooters. Nevertheless, it's okay for us to be surprised that we are in fact alive. So if the 100 sharpshooters all miss, what are you concluding? The game was rigged, right? Somebody substituted blanks for every bullet. And so I should be expecting like the Batcopter to come over the prison wall and lower a rope to let me escape, or the warden really wants me, No, 100 sharpshooters are not going to miss. And so if they do, does that mean, well, in an infinite universe, there's bound to be a time 100 sharpshooters miss? At some point, you've got to decide what's more reasonable, that the 100 sharpshooters miss, or that there was a design here for why I did not get shot by these 100 guys, okay? So to extend this argument, since I'm alive, you could say that it was just an unlikely chance, like wind blew all the bullets away. You may wish to get this survival and attribute it to just a whole lot of good luck, but I really, truly think that, and we saw that with some of the language in those early quotes, I think it's a lot more reasonable. I said rational here, but I think it's a lot more reasonable to think that when you see things being fine-tuned, it really is the Goldilocks principle. Things here are just right, okay? They're just right. And so someone must have purposed that that prisoner should live. And I look at this and say that the cause that brought the universe into existence, the source of good that allows us to know evil is real, and the designer who designed that blood clotting cascade that we mentioned last week, and the designer that set all the dials exactly where they had to be on all these different constants, and we only touched the surface, cares enough about us. It's not just the universe, the earth itself, to show a design and care to make sure we can be here, life on the earth. That to me suggests a personal interest, okay? Once you get through with these, and I only have a couple of more arguments for the existence of God for us to go through, but once you get through with all these things, you then have to ask the question, okay, fine, there's a cause out there. There's a designer. What makes you think it cares about me here in this huge universe? Why should I think that this designer would care enough or want to communicate and tell me something that they want me to do? You've got to have that bridge, right? Would this creator communicate to humanity? Well, it seems unlikely that this creator would communicate with a dandelion, because the dandelion itself, right, has no cognitive processes. So if a creator were going to communicate with a life form, it would have to be something you would imagine that would be able to think. And so to me, it's the fine-tuned nature of things that suggests that this creator, in fact, would communicate and care. I'm going to bring in the Bible. I know I said we weren't going to do that, but how interesting that things are exactly the way they need to be. And how is the original creation by God described in Genesis 1? God did things and it was what?
Good.
Good. He looked at the whole creation and said, it is very good. Moses, if he were inventing that out of whole cloth, which is what the non-religious view would be, or somebody in the Babylonian captivity just writing these things and making up stories, wouldn't have any clue that the universe is designed and that the universe has all these qualities that are exactly like they need to be. Yet that's what Genesis says about the creation.
But he said there was one thing that was not good.
It was not good for man to be alone, absolutely. Which he never says about woman. He never says it about woman, says it about man. So I really look at this, that the incredible fine-tuned nature, just like the prisoner surviving when 100 sharpshooters miss, the fine-tuned nature, I think it is very reasonable to say, this is incredible that all these things are exactly the way they need to be, because think of the prisoner surviving, right? It's perfectly legitimate for the prisoner to say, wow, I really shouldn't be here, but I am. There must be a reason for it. And so that's what I look at with the fine-tuned nature of design. And believe it or not, that's it.
So what's next week? Is it
It's worse.
Chemistry 202?
No chemistry.
So,
No chemistry.
is the fine-tuning, when you think about all the forest fires, all the flooding that's happening, with nature's out of sorts, it's hard to imagine that there was fine-tuning.
So let me address that
It
for a
is
second.
easy to imagine that something needs to be tweaked.
So forest fires.
They're necessary.
We were in the Everglades last week.
Oh, really?
Forest fires are needed for pine cones to release their seeds, for saw palmetto. When we suppress forest fires, we have a different ecosystem in Florida, deciduous hardwoods. And so lightning strikes and forest fires are a natural part of that ecosystem and designed that way. We suppress it, and then when it happens, oh, that's horrible. Flooding. I can tell you, I design stuff. We don't do stuff in floodplains, but when we say something flooded, why? That's a river basin, or that's a coastal construction zone. So when we say these things happen, we got to think, we developed in a floodplain, or we created so much runoff with our development practices that a storm event, a 50-year, 100-year storm event, now has nowhere to go because we've paved and roofed everything. So
That could be. So the fine-tuning is being abused, if you will.
well, no,
Progress.
we build, and we want things to be a certain status. We don't want fire near our homes in the woods. We don't want our streets and our business to be flooded. But if you step back, the Indians, the Native Americans, didn't have this problem, right? They knew where to develop, where they laid lightly on the land. So on those two examples, I would say it's us building in ecosystems that have dynamics and wanting it to not be that way. Hurricanes always existed. The Seminole Indians built oyster mounds in the Everglades to get above the hurricane elevation. So, that wasn't like there's some man-made event there. They just dealt with it.
So imagine that you found Aladdin's lamp, right? And you get 3 wishes. Sometimes, if you were thinking about that, somebody might say, no more hurricanes, we're doomed. Because that would mean the heat in the tropics would go crazy. Hurricanes take heat away from the tropics toward the colder areas. We just happen to build our $1 million houses right on the coast, and the hurricanes periodically come through and run over.
Or volcanoes. People that build inside of
Or
volcanoes.
think of San Francisco. Is it likely San Francisco is going to have another earthquake sometime?
Yes.
Probably, right? Do we know it's going to have an earthquake sometime in the future?
No.
Sure. It'll have another one at some point, right? We still have huge city right there.
Yeah,
So
well-
it's us building on places. And the earthquake, why is there an earthquake? Because you've got plate tectonics, which are necessary to recycle the surface of the earth, which if you didn't have, much like if you didn't have forest fires, the ecosystem, it actually chokes out the growth. You have better forests if you have periodic burning of the forest floor.
Yeah, I understand that. So what about, imagine that all of us here and Al Gore believe in global warming. So if that is a true phenomenon, then something's out of sort.
Well, if that is a true phenomenon, it would be our fault for the Industrial Revolution pumping so much CO2 in the atmosphere. Again, the Indians weren't having concerns about global warming, and we did come out of an ice age a few years ago. There was the year without the summer in the 1800s. The London River used to freeze over. So and they also have the theological import, right? I wouldn't bring this up to somebody who doesn't believe, but the world's not the way God designed it in the first place. We're in a fallen world. And so I don't know exactly what effect that has had on things, but Adam was told the ground is cursed because of you. From now on, to get bread out of this, you got to deal with weeds. What would it have been like if sin hadn't entered the world? I don't know. We can't see that world.
So Phil, I use this example in a debate with one of my surveyors arguing global warming. He's a surveyor. And I said, Wes, do we measure distance over land same way we did 100 years ago? Well, no, we have satellite, we have lasers, it's super precise. So I say, if we go out and survey an 1894 church boundary, is it going to be exactly the same? Well, no. I'm like, so does that mean the earth is shrinking? When we measured temperature 130 years ago, somebody went out and looked at the mercury thermometer within, and made an estimate between degrees. Now we can get down to the thousandths place on a digital gauge. So the margin of error that we're talking about can almost be chalked up to the difference in measuring devices. So when we go out and survey a 130-year-old church, and it's not the exact same as that 1894 plaque, that doesn't mean the earth is shrunk. It just means we measured that. I didn't convince him. I did not convince him. Sir?
Well, the thing is, right, humanity changes the world. And so some of these things can be our fault. There have been studies that suggest tornadoes have gone up in frequency because of the clearing of the land and the paving of the land.
So it does come down.
But that's us.
However,
it's not saying that the fine-tunedness was off in the first place.
But
so it's possible.
It's possible, but let's do this. 1930s, Wichita, Kansas.
Sure.
You're out 10 miles from Wichita. A tornado hits. One family sees it. They may or may not make the paper. Now, 10 miles outside Wichita, tornado hits. They're videoing, it's uploaded, and it's viral within minutes.
Sure.
So we're aware of more things also.
I don't disagree with that at all. That's very true.
But technology has allowed that sort of thing.
But the information overload, it seems like it's happening with more frequency, but we're living in places that we used to not live, and we're reporting on events that used to only be seen by a few witnesses.
So the point for me for the design argument is that you really have only two options. Aren't we lucky? Right? That all these things are just the way they are. Somehow my stomach developed hydrochloric acid and a way to contain it at the same time. Right? Without burning a hole through my stomach. Or choking to death on something that was no acid to, or dying because I couldn't digest something I ate. And the same thing for all these constants and things like that. The blood clotting cascade. All of those crazy steps that I was trying to mimic through last week and doing a poor job, all have to be there or we bleed to death. The first animal that got cut would have bled to death and it wouldn't have been anything. So I think personally it's unreasonable to just say we're a lucky set of chances. Any more than if you told me you solved that Rubik's Cube when you were wearing a blindfold, I would think you were telling me a lie because I wouldn't believe you. What's more reasonable, right? If you put God off the table, and that's what a lot of science has done, then they don't ever talk about God because that's not an option. Oh, really? We're talking Sunday school in the science lab now? I mean, that kind of stuff, right? Whereas if you allow God and design and designer to be part of the picture, then maybe that'll help some things. We already have scientific disciplines that use design. Remember last week, archaeology, search for extraterrestrial intelligence. We assume design can explain some things, but we're not allowed to do that in some of our disciplines. God can't be the answer, so whatever's left has to be true. But that's the end of my class. Any other questions anybody wants to ask?
James.
Comments, anything? Back there?
You can go off. I'll tell you something else.
I do appreciate everybody staying awake.
Oh, this is better than the flying was good.
We had an SLA conference and a
Oh, sorry. Join us next week. And by the way, come down and see us. Have coffee next week. Oh, let's have a closing prayer first. Brett, would you do it?
Dear Lord, thank you for letting us be aware and having the instruments and abilities to realize just what all you've done to put us here. Lord, we recognize you and your handiwork. We praise you for it. Thank you for letting us be here and to be your children. Lord, take us with you someday. Bless us all for being here tonight. In Jesus' name, amen.
Amen.